All right, so I'm going to switch to the dot cam. All right, so our first example just says solve the right triangle with the given information. Right, and again, that means I'm looking for, I'm going to write here, angle A, angle B, and angle C, as well as, put a little line here, side length A, side length B, and side length C. All right, so they've given us two pieces of information. We know angle B is 54 degrees, and we know side length C is 15 degrees. Remember, the capital letters are for the angles, the lowercase letters are for the side lengths. Okay, and I know this is a right triangle. We're solving the right triangle, so I'm just going to put in the information that I have. Here's A, B, and C. Side C is 15. Angle B is 54. We don't know side B. We don't know side A. And we don't know angle A. Okay, so now that we're given a side length and an angle, well, we can find what angle A is just using the information inside. And don't mix up side lengths and angle measurements because we can't compare the two. Right? So I'm just going to use the fact that I know 90 degrees, I know 54 degrees, and I'm missing the third angle, but all three should add up to 180. So if I say 180 degrees is supposed to equal angle A plus angle B plus angle C, I'll just plug in the two that I know and find the missing angle. So I'm going to put angle A I don't know, but B is 54, C is 90. All right, so if I add these guys up and subtract them from 180, so I'm going to take 180, subtract the sum of 54 and 90, and I get 36 degrees. So the missing angle is 36 degrees. All right, so I know angle A is 36 degrees. We actually already knew angle C was 90 degrees. There has to be a 90-degree angle because these are right triangles. It has to have a 90-degree angle. Now my only job is to find sides A and B. All right, so I'm going to put here 36 degrees. And I realize you didn't see any of that math work. Sorry, guys. Okay, so, but it is simple. Just plug in the angle measurements that you know, add them up, subtract from 180, find the missing angle. Okay, so for side A and side B, we have some options. So I'm going to just go with side A first, just because A is first here. If I'm looking for side A, I have some options. I can use any angle that I want, any acute angle that I want, and use a trig ratio. So I have options, which sometimes makes work a little harder just because we feel like there should be one way to go at it, and there's not. There's a couple of ways I can go at it. So what I'm going to do is say it's just safe to use the given angle. If I made any mistake with this 36, maybe it was supposed to be 26 or it was 46, if I made any mistake here, that mistake is going to carry through all my calculations. So I'm going to use the angle that was given, 54 degrees, and just start labeling my sides. This is the opposite side, this is adjacent, and this is of course the hypotenuse. And now I can say, well, I know the hypotenuse, I'm looking for the adjacent side. There's only one trig ratio that uses adjacent and hypotenuse. Okay, so I'm going to put up here SOHCAHTOA. And I say, well, what trig ratio uses adjacent and hypotenuse? Because I'm not worried about angle side B right now. Just looking for the adjacent side. I know the hypotenuse. Oh, that's cosine. I'm going to say, all right, well, cosine of angle B, 54 degrees, equals adjacent over hypotenuse. All right, so now I have an equation. I can find A because it's the only thing missing. By multiplying both sides by 15, I get 15 cos of 54 equals A. I plug this into my calculator. I know what angle A is. Now you do have to make sure your calculator is in the right rate units. So I'm going to go and check. The mode is degrees. It is, so we're good there. And then I'm just going to type in 15 cos 54, oops, 15 cos 54, close that up. I get 8.816, so I'm just going to round it off to two numbers after the decimal, 8.82. So now I know angle A is 8.82. Side A is 8.82. For side B, I now know two sides. I could use Pythagorean theorem. If you like Pythagorean theorem, you know A, you know C, you can find B. Or if you just want to keep with the trig, you can use another trig ratio and find side B. I'm just going to stick with the trig and say I'm looking for the opposite side. I know the hypotenuse. Again, I want to use the given sides and the given angles just because if I made any mistake here, and this is really an approximation, that mistake will carry through my other calculations. So I want to use what was given so I can eliminate as many small mistakes as possible. So I'm looking for side B, which is the opposite. I know the hypotenuse. The only trig ratio up here that uses opposite and hypotenuse is sine. Is sine. So I'm going to use sine of angle 54 equals opposite over hypotenuse. We're running out of space here. All right. So sine of 54 equals my opposite side over my hypotenuse. And just like with the cosine, if I multiply by 15 on both sides, I get 15 sine of 54 degrees equals B. I'll plug that in my calculator, and now I have side B. So I have 15 sine of 54. That's 12.135. I'll round it to two numbers after the decimal, so 12.14. All right, so I've solved the right triangle because I know the measurements of all three angles and I know the side, all three side lengths. All right, so let's try another example, but the difference is this example, I'm only given two lengths. So I'm going to draw my triangle. I'm looking for, actually gonna, I guess I'll just put a little spacer. All right, so I'm gonna look for angle A, B, C. We already know C is gonna be 90 degrees. That one's already a given. And then I'm looking for side A, side B, side C, but I'm already given that side B is 1.32. and side C is 9.45. All right, one quick check is your hypotenuse should always be the longest side, so if you ended up with something bigger than 15, let's say, for one of these two, something was wrong, right? You go back and just double check your numbers. All right, so let's draw the triangle that we have. We have angle A, B, and C, and then we have side length A, which is across or opposite of angle A. I don't know that one. We have side length B, which is 1.32, and we have side length C, which is 9.45. All right, I know two side lengths. I don't really know much about the angles except the 90 degree, which is always a given. So because I know two side lengths, I'm going to go ahead and use Pythagorean theorem to find the third side length. So I have that a squared plus b squared equals c squared. We can always use that with a right triangle. I don't know what a is, but I know that b is 1.32, and I know that c is 9.45. Okay, so then I plug in a squared plus 1.32 squared is going to be 1.74. I'm not going to cut off in my calculator. I'm just going to cut off when I'm writing here, just so that I don't have to use too much space. And then 9.45 squared gives me 89.30. All right, and of course subtract 1.74 on both sides. So I'm just going to take this answer, subtract 1.7424, use as many decimals as possible. So that means a squared is 87.56, and then I'll square root both sides. So square root that answer. I get that a is 9.36 if I round it off. And again, C should be my largest side or my longest side. So if I got an answer larger than 9.45, I'd have to go back and check my math. But we're good here. All right, so I know all three sides. Now I need to figure out the angles. Anytime I need to find an angle, we have to use inverse trig. Okay, so we'll just start off first by saying, well, we know, let's say here, I'm just going to start with angle A. Here's angle A. Opposite side we know, but again, I don't like to use the side length that I found that I calculated because again, it's an approximation. I cut off some of the decimals. I could have made it a mistake. That mistake will carry through. So I'm just going to use the sides that I know. So I don't want to use the opposite side, but I'll label it there anyways. I have the adjacent side, which was given, and I have the hypotenuse. So I'm going to use adjacent and hypotenuse to figure out angle A. It's my choice to choose any trig ratio, but I'm going to use adjacent and hypotenuse because those are the two given sides and I'm not using any approximations. So the only trig ratio that uses adjacent and hypotenuse here is cosine. So that means I can say cosine of angle A equals adjacent, just put a little line here, over hypotenuse. And here I'm looking for A. How do I untrap A? Right now A is kind of trapped and connected with cosine. How do I undo that cosine? I use cosine inverse, right? So I'm going to say A is cos inverse, arc cos if you want, of 1.32 over 9.45. Type that in my calculator, and I'm making sure my calculator is giving me degrees, right? So we've already checked that it's in degree mode, but just double check you're in degree mode, okay? And then I want arc cosine, or the inverse of cosine, of 1.32 divided by 9.45. Close that up. Gives me 81.97. Okay, I'm going to put here angle A is 81.97. And now that I know 90 degrees, I already knew. Now that I know 81.90, put here 81.97, I could just use the fact that all three of these angles add up to 180, find the missing one. So I have 90 plus that 81.97. If I subtract those from 180, that tells me that my other angle, my missing angle, is 8.03. Ignore the negative there, right? It should be 180 minus the answer. So it's just 8.03 degrees. So everything here is in degrees. So now I know angle A is 81.97 degrees. Angle B is 8.03 degrees. We're good to go. How do I know my answers are at least reasonable? Well, we check. The smallest side length should be across from the smallest angle measurement. The largest angle side length, should be across from the largest angle measurement. And then the medium, or the one kind of in between, should be the angle that's medium or in between. All right, so we can kind of just double check that way. Okay, so I'm going to stop the video now. This will be part 1, and then we'll talk about angle of elevation, angle of depression, so that when you start reading some application problems and they're using those terminologies, you'll know what to do.